This video, I will be answering activities under my Laboratory 5, examining the flags in Microprocessor Microcontroller System and Design course. Okay, so for activity 1, write and assemble a program to add the following data. So the first thing that I will do is to use the instruction LDI to store the following data in different registers. So I will start in R16 to store 92 hex, R17 to load 23 hex, and LDI R18 to load 66 hex, LDI R19 to load or to store the data 87 hex, LDI R20 to load the data F5, and I will assign a register which is the R21 to serve as my sum location, or the final location or destination of the sum of these data. So after loading all the datas, I will add them. So to add the first and second number, I will be using the instruction add, and I want to store them in R17. And the next is I will add the third and fourth number, and I want to store it in R19. And then I will add the last and fifth number and store it to R21. Next is to add the sum of this one and this one, and I want to store it in R19. And last is to add this line. Last is to add this line and then this one. So R20, I want to store it under R21. This line and this line will be stored in R21 as my final location. Okay. And don't forget to put this command. So the last line will still be processed. But before simulating this program, I will put here first the equivalent binary of the datas, for I will be able to explain better the conditions that will be given by the status registers. So I will be using online calculators and base converter for the sake of making it faster. Since this is hex, I will change it hex. For 23, for 66 in hex, 87, F5. So now I will be doing the arithmetic. So I will add the first and second line and store it to R17. So 92 plus 23. So the answer is B5. And in binary, so adding the fourth and third line, 66 and 87. It's binary equivalent. And for the last instruction, add R21 and R20. So this is still F5. F5 binary equivalent is, now we will be adding R17 and R19. So B5 plus ED. So the answer is 182. Adding 182 to F5, the answer would be okay, so the answer is 297. Now let us simulate and then examine the CHZ flags after execution of each addition. Okay, so I will be pressing F11 to examine each line of code. So we load 92 to R16, we load hex 23 to R17, we load 66 to R18, load 87 to R19 in hex, we load F5 in hex to 20, and we load 0 in hex to R21. So there's no reaction or condition given by our status register when we are loading data or when we are storing values inside a register. So now, let us observe this line. So adding R17 and R16, which results to B5, or in this binary, states a condition in our status register concerning CH and C flags. So our C remains 0, or it is not highlighted, because when we add the first two numbers, there is no carry on the 7th bit. We just bring down the 1. The C flag is not activated, or our C flag is 0, since adding these first two numbers resulted into B5, and it is not equivalent to 0. For the H flag is also 0, or it is not activated, not highlighted, it is not blocked, because there is no carry in adding the D3 of the two numbers, and there is no carry going to the D4. So 0 plus 0 is just 0. Adding R19 and R18, 87 plus 66, so we have the H bit. Since we have here on the D3 and D3 here, so 1 plus 1 is 0, carry 1, so we have a carry from D3 going to D4. Adding R21 and R20, you have F5 and 0. Our C flag is not equal to 1 since there is no carry on RD7 because it's like 0 plus this number, plus this number. And then our H flag is not activated or is not equal to 1 since there is no carry from D3 to D4. Our 0 flag is also equal to 0 since the sum is not equal to 0. The next line, adding R17 and R19, we have the B5 plus ED. So looking on the H flag, it is black, it is equal to 1. Since adding this one, we observe that the D3 of this one and this one is equal to, both equal to 1. So when we add them, there will be a carry going to D4. So our C flag is also activated. C is equal to 1 because adding R19 and R17, looking on the D7 bit, okay, this one. So 1 plus 1 is 0, carry 1. So there will be a carry coming from our 7th bit. For the C flag, it is equal to 0 since the sum of adding those numbers does not equate to 0. So it didn't turn to black. For the last command, so adding R21 and R19 have a condition wherein our C flag is 1. Thus, adding R21, this one, and R19 will be having carry from our D7. So 1, 2, 3, 4, 5. So this one and then this one. So 1 plus 1, there will be a carry from our D7. Our H flag, so it's not activated because looking on R19 and R21, this is R19 and then R21, D3. So 1 plus 0 is just 1. So there will be no carry from D3 going to D4. And for what else? For the Z flag, so the Z flag remains 0 since our sum in adding R21 and R19 is not does not equate to 0. So the sum of these data is equivalent to 97 in hex, and they are stored in R21. So that's for activity 1. Now let us proceed to activity 2. Write and assemble the following program. So in activity 2, the program is already given. So what will I need to do is to simulate and then examine the flags and register content after the execution of each instruction. So I will remove this. First thing that I will do here is to get their binary equivalent for better examining the flags. 15. So subtracting R20 and R21. Answer is 12 and it's binary equivalent. Binary equivalent. It's 12. 20 hex to R20. 15 to 21 to R21. And then subtracting R20 and 21 and storing it to R20. 20 minus 15. Answer is 95 is a decimal number, so we have to change the base from hex to decimal. That is 95. Since they are just the same, I will just copy it. Subtracting 95 minus 95, I assume this is 0. Okay, so loading 50, still in decimal, because there is no dollar sign. And 70. Okay, and subtracting 50 and 70 is negative 20. Okay, this is equivalent to negative 20. Oh, now we are ready to simulate the program. Okay, so for activity 2, let a single step each. So loading 27 to R20, loading 15 to R21, and then you have to subtract 15 from 27. The answer is 12 according to this. Its equivalent binary is this one. So when we process this, there is no reaction from our status registers. Since on C, as we can see here, we don't have carry from D7. That's why C is not activated. And then Z flag or the 0 flag, since the difference of R20 and R21 is not equivalent to 0, that's why this C flag did not activate, did not turn to black. And then the negative flag, so we don't have this D7, it's not equivalent to 1, that's why it's not turned to black. And then the V, since the difference is not to complement or a complement. And then S is not highlighted since both V V flag, and then N flag is not activated. So that's why S is not activated. And then our half carry flag is not activated since there we didn't have a carry from D3 to D4 since we did a subtraction, and D3 here 1 minus 1 is 0. So there's no carry. That's why it also didn't turn to 1, or it didn't turn to black. Proceeding to this line. So we load 22, register 20, and then we load 15 to R21. Subtracting R20 and R21, the result is B, and this is its binary equivalent. Subtracting R20 and R21, we have here the resultant or condition on the status register, which is H. So meaning that we had a carry from D7. As we can see, we subtract this binary here. And we can see that this one is 0, while this one is 1. So we had to borrow here, and then this will become 0, this will become 2. This 4 zeros here will become 1, and then this one will become 2. So there is a borrowed or carrying happened. That's why H flag is activated or it turned black. So for the next line, we have to load 95 decimal 95 to 24. Oops, I modified it. So let's start. Let's restart the program. So let us proceed in this line. So we will load decimal 95 to R24. Yan. It changed to its hex form. Okay. And then the next line, we also load 95 decimal in R25, which turned into its hex form. And then subtracting R24 and R25. So assuming or just looking on the same number, of course, it will be 0. Okay, so our Z flag is activated since the resultant is 0. And then we proceed to the next line. We load decimal 50 to R20, and it was changed into its hex equivalent. And we load 70. Now let us load 70 to R23, which is 46 in hex. And then subtracting R22 and R23, or 50 minus 70, is negative 20, according to the calculator that we've used. And let us see the status registers. So C is activated, indicating that we had a carry from the D7 on the D7 bit. So subtracting this from here, it cannot be. So we will going to borrow. In that case, we will going to add another bit, which will make our difference equal to a negative number. So that's why our N bit is black. S is activated too because either V or N, since V is not activated but N is, that's why it is also activated. We also have here the H or the half carry flag, since we had some borrowing happened here for us to be able to subtract them. So on the D3 and D4, since here the D3 is 0 but the D3 here is 1, so we have to borrow from the number next to it. That's for activity 2. Now let us proceed to activity 3. So write and assemble a program to load the value. Okay, so the program in activity 3 is already given, so I will just simulate it to examine the status registers or the flags after executing each instruction. But first thing that I will do is to get the equivalent binary of this data for the sake of better discussion of why we are getting such conditions from our status registers. So 0, let us leave that as 0. So for the hex FF, it's for hex 11, for 22. Okay, now let us simulate it and then examine the flags. I will be pressing F11. Let us load 0 to R20, and then load FF to R21. Load 11 to 22 in hex, and then let us load hex 22 to R23. Now we will be getting the complement of R20, which is 0. Okay, so we have the S and C flags complementing R20, which is 0. Our status registers raises flags S and C. So we had the C flag. Since it's assuming that there is a number added to a 0, that's why it became 1 1 1 1 1 1 1 in binary. So we also have here the N flag for the negative flag. Since if we get the complement of 0, this will become 1, or which is also equivalent to 1, 1, 1, 1, 1, 1, 1, 1. Since we have 1 here on the D7 or bit 7, that's why the N flag is highlighted, and as well as the S, which is the sign flag, indicating that the sign should be negative. And since it's either one of these or one of these is highlighted, and that is N. Okay, so next. Okay. Since the program is modified, we have to restart it. And then proceeding to complementing R21, we got C and Z flags. So the complement of this one is 0, 0, 0, 0, no, 0, 0, 0, 0 of R21. So since our the resultant is 0, that's why we got 0 flag. And in order to change it to 0, the system assumed that we had a carry flag in order to get its complement, in order to get the complement of 1. So next, to proceed with the home R22. I will rebuild again the project because I wrote something on the program. So for this line, the complement of R22 is 0, 1, 1, 0. So we have the flags S and C. We have the S flag indicating the sign, which is negative. And then we also have the carry flag for complementing R22. And then lastly, for complementing, okay, so modify. Lastly, for complementing R23, which is that number, we also attain the S and C flag. So when we are getting the complement of a number, we are getting the N flag. N flag, since complementing is like negating a number or getting its opposite. And then we have the S flag or the sign bit indicating that the sign of the resultant should be negative, since N is also activated but D is not activated. Complement of R23, 0, 1, 2, 3, 0, 1. We have the carry flag since we are considering complement of a number, and the system assumes that we are adding a number to that number in order to get its complement. So that's for activity 3. For the last activity, activity 4, we were given letters A, B, C, D. So in this activity, find the value of the C flag after the execution of the following codes. So I will focus on the C flag in executing this given program. So for letter A, I already clicked the simulation button. For F11, we load 85 to R20. We load 92 to R21, and when we add those numbers, okay, so C is 1 when we activated, C is activated, or C is equal to 1 when we add R20 and R21. So that's for letter A. To know the reason, we get the equivalent of those numbers. Okay, so observing this number, when we add the D7 of both numbers, we will be having a carry from D7. That's why our C flag is activated, or it is equivalent to 1. Next, let us proceed to letter B. Now, I will simulate the program. Okay, so for letter B, we loaded 15 hex to R16 and then 72 hex to R17. Now, adding both numbers, C is not activated. C is 0 since it did not turn black. Now, the reason behind, we will get the binary equivalent of these numbers. Okay, looking on the D7. So when we add these two numbers, looking on the D7, 2, 3, 4. Okay, so we do not have carry here because this is 0 and 0 plus 1 is just 1. That's why our C is not activated for letter B. Okay, now let us proceed to letter C. On the first letter, C is equal to 1. Here, C is equal to 0. On letter C, we load F5 on R25, and then we load 52 hex on R26. So when we add those numbers, our C is 1. So our C is 1. C is equal to 1. C is equal to 1. So to know the reason why, let us get the binary equivalent of F5. Okay, so when we add the 6th bit, 1 plus 1 is 0 carry 1. So we have 0 carry. On D7, we have 1 plus 1 is 0 carry 1. So we also had a carry on the D7. That's why C is equal to 1 in this program. And now for the last letter, which is letter D. Okay. Let us load this number on R25. FE. It's loaded on R25. So we have the increase instruction. So we have to increase FE. So C is not activated. And then on the last one, C is also not activated. Reason why it happened. FE. Ayan. So let's try to simulate the program. So increasing it will result to FF. And then increasing it again. Increasing it twice will result to 0. Okay. And FF equivalent is 1, 1. 1, 1, 1, 1. So we increase by 1 here. There's nothing that happened on our D7. So D7 is not affected. That's why our C did not turn into black, or C is not 1. Since there is no carry here from the D7. As well as here, although we increased another one, C0 is not C is not affected. Because when we increased FF, we got a 0 resultant. So there's no concern with D7. So that's all in laboratory 5. Thank you for listening.